Hi, in this video I'm responding to a comment that I got asking me if I could help this person on this synthetic division problem, if I could divide these two polynomials. This comment came from my video that I posted actually 4 years ago today about expanded synthetic division. So here's the problem. 2x to the fifth minus x to the fourth minus 5x squared minus 2x minus 3 divided by x squared plus x plus 1. And how do we divide this using expanded synthetic division? Teachers are going to say that you have to use long division, but no, you could use synthetic division for this. So you write out all the coefficients just like in regular synthetic division. So we have 2, we have -1. Now remember that we have a 0x to the cube, or 0x cubed, right inside here. So we have to account for that. So 0 goes right there. And then we have -5, we have -2, and we have -3. So just to be sure that we're doing this correctly, we take 5, the degree of the polynomial of the numerator, we add 1, which is 6. So we should have 6 numbers here, and we do. Now again, this is just the setup part. I'm going to draw a long line here because we have a relatively long divisor. And what I'm going to do next is I'm going to draw another line here, and I'm just going to start to drop down this 2. Now we're still setting this up here. Now ordinarily, if the coefficient of the leading term of the divisor is anything but 1, then I would put like a slash whatever the number is to remind us to divide, but since this is a 1, we don't have to worry about that. Next, I just go on to the next terms and write them up here, but I have to negate these. So this is plus 1x, so this would be -1. We put right down here. Now above it, I'm going to put -1. Okay, and I'm putting it in the stair-step fashion, and you'll see why here shortly. Now it's time to solve this. So just like in synthetic division, you bring down the first number, which is 2. And then you take 2 and you multiply it by -1, and that's -2. So I'm going to put that down here. Now, unlike regular synthetic division, there's another number here. So I'm going to do the same thing, 2 times -1, which is -2. Now I have to put this up here, and that's why I have it in a stair-step fashion or diagonal fashion like this, to remind you that the first number you put down here, and the second number you put above and to the right, underneath the third number. Okay, now I do -1 plus -2, which is -3. And now I take -3, I multiply it by -1, that's +3. I do that again, which is +3. Now I take 0 minus 2 plus 3. Okay, that's going to be +1. Alright, and now on to the next stair step here. 1 times -1 is -1. 1 times -1 is -1. So just to reiterate the diagonal or stair step pattern here. So we take -5 plus 3, which is -2. -2 minus 1 is -3. Okay, now take -3 times -1, which is +3. You take -3 and times it by -1, that's also +3. And now we have -2 minus, or -2 plus -1, which is -3, and -3 plus 3 is 0. Okay, now notice what would happen if we added, or if we multiply 0 with -1, which is 0, we would put that right here. And notice if we do that again, 0 times -1, and put the 0 up here, there's nothing above it. So technically we're done, and this is in the realms of the remainder. So this vertical dashed line is right over here, meaning that this side is the remainder. And then you have -3 plus 3, which is 0. So in this case, this divides evenly. So we don't have a remainder. Now we just look at this right here. Also, real quick, another tip is that you look at the exponent of the leading term of the divisor, or the denominator here, which is 2. And we start here, we go 1, 2, and then draw the vertical dash line. And then this is our remainder. That's just another tip that you could do. So, this is what I would do. I would just start writing the x's here. You don't have to do it here, but just for the sake of argument, I'll just put an x here, x, x, and another x right there, because our variable is an x. Okay, now I start with 0. I do 0, 1, 2, 3. Alright, now x to the 0 is 1, so we don't have to write that. And we're left with 2x cubed minus or plus negative 3x squared, but you could just put minus 3x squared, plus 1x to the first, which is just x, minus 3 times 1, which is 3. And that, in fact, is the answer. And then you could multiply these two polynomials together, and you should get this. So I hope this helps. I'm glad to help, and have a nice day.